Oh, there is another kind of collisions. Collisions can also be defined as head-on or glancing. What's a head-on collision? Yes?
The vectors of the velocity are opposed, directly opposed to each other?
Very true, except if you're in the lab frame. Then that means the vectors could be in the same direction. Head-on collisions in physics are defined as collisions in 1D, mostly. So if you have one mass and it hits another mass and they both move in the same direction. Whereas glancing collisions are collisions that are either in 2D or 3D. So for example, Compton's effect. People who've done Compton effect, what did they look like? Something came in, hit something, and they both moved away like that. Do you remember quantum effect doing that? Yes. Those are called glancing collisions. When two things come together and then they go away. And then you have to do cosines of thetas and sines of theta. Do you remember doing that with momentas? Sines and cosines and in 2D, stuff like that? This is a very classical mechanics construct. All of this math came from there. Okay, so can I just show you one type of collision, the math behind one type of collision? Sure. Should not take us more than 10 minutes if you pay attention. 15. Are we ready? Okay, let's suppose I have a moving target, the most general case, and I have one particle that comes and hits the other one, and both of them are moving, just like you two were. Right? You're both moving in the same direction. What can I do about that collision? One mass, two mass. I'm not saying which mass is bigger, which mass is smaller. I'm just calling it M1 and M2 for now. They are both moving. And they come together. That's called impact. And then they go away. Okay, so we will have V1I, V2I, and then after they go away, something else happens. Maybe they bounce back. Not overly concerned about that, but I'm going to call this final, V2 final. And then we'll do specific cases later. So may I write, there are two main laws we talked about, right? Conservation of momentum and conservation of, there we go. So let's do, which one do you want to do first? Momentum. Okay, let's do momentum first. What is conservation of momentum? True? What is kinetic energy? Will there be potential energy in there? It's just colliding, moving. They're not falling. Even if you do put in potential energy, it's not going to make any difference. It's going to be the same before and after. Okay, so may I write this as M1 V1I plus M2 V2I equals M1 V1 final plus M2 V2 final. And may I write 1/2 M1 V1I squared plus 1/2 M2 V2I squared. Please make sure there's too many numbers to worry about. M1 V1 final squared plus M2 V2 final squared. Well, all of my halves go away. So don't have to worry about those. So I am looking for, given initial velocities and initial masses, I want to find V1 final and V2 final. Equations for those. What happens to those? Are we ready? May I call this equation A and this equation B? I might change them to 1 or 2 later, but so far let's call them A and B. May I write equation A as M1 V1 I minus M1 V1 F equal M2 V2 F minus M2 V2 I. And may I write B as M1 V1 I squared minus M1 V1 F squared equal M2, oh, I should have just done that, M2 F squared minus M2 V2 I squared. I just rearranged them. Yes? May I divide equation A with B? Yeah. Mathematically, I'm allowed to do that? So will ones go away? Will 2 goes away? May I rewrite that expression as V1I minus V1F divided by, this is V1 squared minus V1F squared. Can this be written as V1I plus V2F, V1I minus V2F equals V2F minus V2I divided by V1F, no, 2, oops, plus V2F. Wait, 1 should be an I. This should be an I. This should be I and F, and then V2F minus V2I. So far, so good? Will this cancel? And will this cancel? May I rearrange and write this as V2F plus V2I equals V1I plus V1F. 1F. Right? There were ones. There were ones on one side and 2s on the other side. So far, so good. I haven't done anything complicated yet. Okay. May I then rewrite this in 2 ways? May I rewrite this as V2F equal V1I plus V1F V2I? Or I can also rewrite this as V1F equals V2F V2I minus V1I. Can I do both of these from that? Okay, so may I plug, I'm going to rewrite my equation A again and plug this V2F in equation A. Do that. So first of all, for this one, I'm rewriting my equation A, which was M1 V1I plus M2 V2I equals M1 V1F plus M2 V1I plus V1F minus V2I. All I did was I rewrote my equation A and I put in V2F there. May I rearrange everything to give me M1 minus M2 V1I plus 2M2 V2I equal M1 plus M2 V1F. I just moved a few things around, matched up the VIs, and what was I looking for? V1, remember? That's what I wanted. Do you see that somewhere in this equation? What side do you see it at? Can you rearrange this equation so that becomes alone? Okay, so may I rewrite this as V1F equal M1 minus M2 divided by M1 plus M2 V1I plus 2M2 divided by M1 plus M2 V2I. Woohoo! All done. This looks really complicated. It's actually just algebra. And you can do the same thing to the other side. Take equation A again, plug this value in here, and solve to give you V2F, which comes out as 2M1 divided by M1 plus M2. I am not doing that derivation. It's literally 2 steps. V1I plus M2 minus M1 divided by M1 plus M2 V2I. So remember the steps? You guys should fill in these steps. Okay, now that's done. It looks really complicated, but I want you to do this for yourselves. I want you to do specific cases. So case 1 is when M1 equals M2. What happens to these two equations? Good? Case 2 is when M2 is much, much greater than M1. And M2 is initially at rest. Case 3 is when M1 is much, much greater than M2, and M2 is initially at rest. When it's initially at rest, what will happen to V2I? There we go. That's all. It's just a matter of plugging in numbers. Yay, we're done.